acid I can make
Yes.
ಸುಮ್ಮನೆ ಮಾಡ್ಬೋದಲ್ಲ ಮಾಡ್ಬೋದಲ್ಲ ಬಂದಾರಲ್ಲ ಹುಡುಗರು
ಜನ ಆತರ ಒಂದು 2-3 ಮಿನಿಟ್ಸ್ ಬಿಡ್ತೇವೆ ಮಾಡಿ.
ಆಯ್ತು. Hello, my dear students. Good morning. Today we are dealing with discussing about the carbohydrate metabolism. You know all well that all the humans they consume the food that must be consisting of the carbohydrate, lipids, proteins, everything. Out of that, carbohydrate has got a very prominent importance because whatever the type of food that will be consumed, that will be getting converted to the glucose, which will be absorbed, metabolized, through which the person will get the energy in the form of ATP. So all these processes are combinedly considered as the metabolism in the language of biochemistry. So the metabolism is the one of the important aspect in the life of the organisms or the human mammalians, that it is the very important factor by which not only the persons they get the energy, but also they are the one which are the sources for the overall growth and other functions, everything. So if there is any differentiation in the process of this metabolism, the person may get into the problems with many types of the diseases. So it is the one which occurring at the cell level where there will be lot of the chemical reactions will be taking place, and in this aspect we have to study the way that reactions takes place, which we refer them as the pathways. So we start with the carbohydrate metabolism. This is my introduction. Prior to that one, in the last class, we discussed about the digestion and absorption of the carbohydrate. So I will just want to remind you what we have seen in the last class. So the food consists of, already, carbohydrate, protein, vitamins, all those things which are in the size of a macromolecular one, and which cannot be accepted or taken as such in the body. It has to go through the process called as the digestion. So in the biochemistry, the digestion is referred as the hydrolysis of large and complex organic molecules, which will be converted into the smaller one, preferably the water soluble molecules. So you can see just this flow chart, that the carbohydrate, which may be consisting of this starch, glycogen, sucrose, lactose, they first, the digestion of that one process starts in the mouth, wherein the one salivary alpha amylase enzyme, it comes for the starting of that to be converted into the simpler one, and from the mouth it is entering into the stomach, where there will not be any scope for the digestion because of the acidic nature that is existing in the stomach. From there to the small intestine, where again there will be the enzymes will be there, like alpha amylase, maltase, sucrase and lactase, and they act upon the food and they convert into the monosaccharides. So that will be absorbed, and finally the monosaccharides will be given into the bloodstream or passed on to the bloodstream. This is how, in short, how the digestion takes place when once the person consumes the food. So you have seen in the last class that all these, the carbohydrates, when they undergo the hydrolysis, because of these many enzymes, they undergo the hydrolysis and they get converted into the one where first you see that starch is getting converted into the maltose and dextrin, and another one with the pancreatic amylase into the maltose and isomaltose, and then maltose into the two molecules of the glucose, and lactose by the action of enzyme lactase, it will be converted into the glucose and galactose, and sucrose also into the glucose and fructose. So again, I am telling that they get converted into the monosaccharide, that is the glucose, and that will be accepted by the cells, and that will be as the one which providing the energy. So in short, you can call the glucose as the currency of the body. You can refer that as the currency of the body. Now once the glucose is absorbed, what happens to that absorbed glucose? It is that it is distributed to the cells in the tissues, where it is broken down, or it will be stored. It will be stored as the form of the glycogen. and if still further more amount of the glucose is there, that can be get converted into the fatty acids and it will be stored in the form of the fats. So after that one, when the glucose is available within the cells, these simpler biomolecules, they undergo a series of chemical reactions, or you can call chemical transformations. So which in other word it is called as the metabolism. So when you refer to this and as the metabolism, it has got the certain process are there, chemical processes or the chemical reactions, and these reactions, they are not taking place just one or two in the number. They will be in the number of many reactions, and each reactions are related, interrelated to each other. So they don't occur in the isolation, not in a single reaction will be taking place. They occur in an organized multi-step sequence, and which we call them as the pathways. So we'll come across in future how many pathways are there for the carbohydrate metabolism. So it will be such a sequenced and well organized and interconnected that a product of one reaction can be a reactant or the substrate for the next reaction, subsequent reactions. So different pathways intersect, forming an integrated network of the chemical reactions. So pathway is nothing but an integrated network of the chemical reactions which are dependent on one another, and they will be working in a well manner, coordinated manner, and in a multiple sequence in the form of the pathways, and which we call them as in total as the metabolism. So metabolism should be defined in this way. How that one you see that? It is the sum of the all the chemical changes occurring in the cell, a tissue or the body. It is a collective chemical changes, the reactions. They are referred as the metabolism. However, in for the smooth studying of this one, they are sub-classified as two types, that is catabolic metabolism and anabolic metabolism. Catabolic, in the catabolic, it is a degradation of this one. The complex molecules should be degraded into the simpler one. Anabolic means the simpler one, it will be synthesized or collected to make a complex one. So we give the definition for the metabolism as that it is defined as the total amount of the biochemical set of the life sustaining reactions involved in the maintaining the living conditions of the cell in. Hmm? This is the way we define the metabolism. So there are three reasons or the purposes for the metabolism. One is the main aim of this one is the conversion of the food into the energy, or second one, conversion of the food fuel to the building blocks like proteins, lipids, nucleic acids, and some carbohydrates. Like in the carbohydrates, we call sugars as the monomeric blocks which can be taken into the account to form the complex molecules, whereas in the amino acids we refer that as the building blocks for the proteins. That way the conversion of this food will be converted into the building blocks. And third one is the elimination of the metabolical waste. Many will be there as the waste one at the final stage of the the metabolism. So that has to be eliminated from the body. So all three these purposes will be taken care by the metabolism. And as I said in the previous one, there are two types of the metabolic processes. They are catabolism and anabolism. So what is catabolism? Catabolism is the one which is involved in the breaking down of the larger organic molecules into the simpler one. Means that is the breakdown of the complex molecules into the smaller one. So while doing that one, there will be the release of the energy which we say in the form that is called as the ATP. We all know the full form of the ATP. And further, this process releasing of the energy, it will be taken through the Krebs cycle or oxidative phosphorylation. Krebs cycle is the one which is a central part for the various metabolical activities of the three components like the carbohydrates, proteins and fats. So this is the definition for the catabolism. In the catabolism, there will be the breakdown of the complex molecules or the larger one molecules into the smaller one. So one is the breaking of the larger complex molecules, and there will be the release of the energy in the form of the ATP. And another thing is that catabolism also provides precursors for the synthesis of the complex molecules. So this is the definition for the catabolism. Now coming to the anabolism. It is the process mainly involved in the building up of the synthesizing compounds from the simpler one required by the cells, and it is the process which requires the energy. So from the simpler molecules, the things will be constructed or synthesized, that will be referred as the anabolism, and for this purpose it requires the energy. So all the larger molecules are made from these respective monomers, which in turn are synthesized from the new precursor molecules. So you must know what is the difference between catabolism and anabolism. Catabolism means it is the one by the simpler one, the complex molecules will be broken down into the simpler one, and when the broken of these complex molecules will be taking place, there will be the release of the energy. Whereas anabolism is the one which is involved in the building up of the simpler one into the complex one, and in this process they require the energy. This is the basic difference between catabolism and anabolism. So it should be noted that they are not reversal for each other, but they operate as a independent pathways. Means they are not exactly opposite to each other. They are working in the coordination and in support of both of them, but they have got their own independent pathways. They have got their own independent pathways, and they are reciprocally regulated by various mechanisms. So the breaking of that one or the building of the complex molecules, all these will be regulated properly at the different stages, and they will be maintained by the regulation has to be there. Otherwise, there won't be any control for this, the either the breakdown of that molecule or the synthesis of the new molecule. So when there is the impairment, that leads to the any such some diseases. So these are the two things which work independently, and they are, but they are not working in opposite to each other. But however, there is one uh, pathway is there which may be having both the things, that is catabolic and anabolic, both will be existing in that system. That one is found in the Krebs cycle or citric acid cycle. So anabolism, catabolism and a amphibolic pathway will be there, that is applicable for the citric acid or Krebs cycle. Okay. So you can see here that simple molecules, when they are glucose amino acids are there, they will be taken into the anabolic reactions and transfer the energy from the then to the complex molecules. Heat will be released in the catabolic one, and these complex molecules, so they undergo catabolic reactions and release the ATP molecules. So this is a round the clock system or clockwise direction. You can show the reactions or the pathways that they take place. Okay. Now let us come to the metabolism aspect of the carbohydrates. In the carbohydrates, the metabolism of the carbohydrate means it is ultimately the metabolism of glucose only. We can assume that way because the whatever the carbohydrate we take in the form of any type of the food, whether it may be a disaccharide or polysaccharide, that has to be converted into the mono carbohydrate, and that is that also the sugar only, that is glucose only. So glucose is the major fuel of most of the living forms. It occupies the central position in the carbohydrate metabolism because as all those molecules they get converted into the glucose, the importance lies with the glucose metabolism, and it is an exclusive source of energy under the normal conditions. That's why when the persons feel hypoglycemic, we measure the glucose or the sugar estimation only we do to check that one. We don't estimate any other the carbohydrate like lactose or mannose like that one. We cannot that way. So we have to refer to the glucose only. So glucose is oxidized and used as the fuel synthesized from the non-carbohydrate sources, also can be stored as the glycogen. It means that when there is non-availability of the food or the glucose, then what body will do? It will take the sugar from the stored one, that is the glycogen, and also the another source from the fats, whatever it is stored there, by the another form that is called as the gluconeogenesis. That pathway we come across later on. So ultimately what happens? It has to provide the glucose to the body for the further actions or the activities. So metabolic pathways, they allow the energy with the glucose to be released. That is the one where the glucose has got the importance, and breakdown of this glucose that results in the giving the energy or in the form of the ATP one, and it all these things indicate that we can say that metabolic pathways in the carbohydrate metabolism, either they start with the glucose or they end with the glucose. So much the prominent role that glucose has got in the metabolism of the carbohydrate. So hence carbohydrate metabolism means it is the metabolism of the glucose only, because all the monosaccharides formed after the digestion, they are interconvertible into the glucose which is used by the different tissues. So when you study these pathways of the carbohydrate, you can see that the things are there. There is the presence of glucose only, either at the start of the reaction or at the end of the reaction. So you can claim that the carbohydrate metabolism means it is the metabolism of the glucose only. Now, coming to the metabolism of the carbohydrate importance, it can be little bit regarding the medical aspect or the clinical aspect and the biological importance. So, one may ask you to give the biological or medical importance of the carbohydrate metabolism. That time you can refer these points and write your answer. Glucose is the major fuel for all type of the cells in the body, that which you have learned already, and its oxidation produces the energy. And another main thing is that brain is the one organ which prefer glucose as a fuel rather than fat and protein one. So the very immediate need for the brain is that there should be the supply of the glucose to it. Otherwise, you must have observed or heard about that a person who will be feeling short of the glucose, he feels that he is nervous or he is unable to even think properly if this hypoglycemic situation is getting worse by time. So for the brain, there must be there a continuous the supply of the glucose, and brain is dependent on the glucose as a fuel rather than the fat and protein. And another thing to be noted here is that brain consumes about 100 gram of the glucose per day. On this one, you can imagine that how much amount of the glucose should be there in the body so as to safeguard the brain. And if the glucose is not available, as I said, the body will have the arrangement for itself to get the glucose supplementation by the non-carbohydrate source, that is called as the gluconeogenesis, which we will study later on. And another thing that the rate of glucose oxidation, it is more in the cancer cells, because the cancer cells will be in need of, or they will be literally they are hungry of the more amount of the glucose. So what happens in this one, the rate of oxidation of the glucose will be more in the cancer cells, because the cancer cells, they want the energy for to have their growth. And another thing what happens, sometimes the person may be feeling of or having the diseases because of the lack of or partially absent of the enzymes which are involved in the metabolism of the one which is related to the glycogen. They may cause the glycogen storage disease. So this one we will discuss in the end of other classes, which will be referred to as Bongrike disease. So these are the inborn errors, it will be there, where they will be lacking some of the enzymes that are required for the processing of these metabolical reactions. It means the deficiency or absence of this one will lead to the glycogen storage disease. Similarly, in the metabolism of galactose and fructose, same thing happens when there is the absence of the related enzymes are there. So they may cause the galactosemia and fructosemia. They may happen, and they also will be similar to the glycogen storage diseases. And one of the prominent observation that when there is the deprivation of formation of the glucose or availability of the glucose to the cells, then nowadays the very common the metabolic disease is there, that is referred as diabetes mellitus will happen there. And nowadays even it is claimed that the India is becoming the capital city for the diabetes mellitus. You may understand how much the importance is there for the glucose, and we must know about the metabolism of the glucose or the carbohydrate. And it is not just pertaining to the diabetes mellitus to occur, it will be the real culprit for the development of another diseases. They can be the hypertension, kidney diseases, or the blindness. So these one, when you look at, many of the patients will be suffering from the diabetes mellitus. So the cornerstone of the blame will be on the diabetes, that the deprivation of availability of the glucose to that person. And the obtained glucose is utilized in many pathways to provide the energy, storage, fuel, glycogen, and important compounds like ribose, gluconuric acid, etc. So, the metabolism of this carbohydrate or the glucose, they will be providing the another two important things which are required for the body, that they are ribose and gluconuric acid. So you may be knowing about that ribose is the one part of the RNA. So all the pathways are well coordinated and regulated to ensure the normal blood glucose and functions in the body. Means the overall intention of this metabolism will be to have a well regulated and coordinated system, or the interrelationship between the all these chemical reactions in the form of the pathways, to see that there is the normal blood glucose level will be there. The fasting blood glucose between 70 to 110. Nowadays they have brought down it to 100 milligram per deciliter. So the main target, the idea or the motto will be that the blood glucose level should be in the normal or well controlled one. So that what happens, it will not be leading to any other further complications like the hypertension or the renal failure or cataract formation or night blindness, whatever all those things will happen. When you see that one, most of them will be suffering from the diabetes mellitus. Now, metabolic fate of the carbohydrates, we see that one. Once the glucose or the carbohydrates are absorbed in the from the intestinal tract, these monosaccharides are carried by the portal circulation to the liver. Once they will be absorbed from the intestine, they will be carried over to the portal circulation to the liver. So in the liver, once there is the entrance of the glucose is there, it gets converted into one molecule that is called as the glucose 6 phosphate. The immediate reactions will be that glucose will be converted into glucose 6 phosphate, and this glucose, it will be trapped within the cell and it cannot diffuse backward. Means once it enters the cell, it will be converted into the glucose 6 phosphate, but it won't be going back again out of the cell. It gets trapped there, and because the plasma membrane is impermeable for the glucose 6 phosphate, so you can claim in this way that it is irreversible reaction. Means once the monosaccharide or the carbohydrate glucose is absorbed at the intestinal level. It will be carried over to the portal circulation to the liver. After entering in the liver, it will be the glucose will be converted into the glucose 6 phosphate. When once this glucose 6 phosphate enter into the cell, it won't go out of the cell. It will be trapped there only, because glucose 6 phosphate has the one which is impermeable to the cell. The remainder of the glucose passes away into the systematic plus blood supply. Means what is the amount of glucose is converted into the glucose 6 phosphate that is entering into the blood, into the cell, and rest of them will be in supplied or passes to the systematic blood supply. So once the glucose is converted into glucose 6 phosphate, there are important pathways of the carbohydrate metabolism comprising the degradation, synthesis of the glucose and the monosaccharides. So just remember it, at the intestine level, the monosaccharides will be absorbed, taken to the liver in the portal vein, and once the glucose enters in the cell, it will be converted into the glucose 6 phosphate, and it will be getting trapped there. Means there won't be the step back process will be there. It will be happening, means it won't go in the reverse way. So it is not going in the reverse way because the cell's membrane is impermeable for that one. So once that glucose 6 phosphate has come in the cell, then it undergoes different types of the metabolic pathways. So they may be requiring, or they may be needed to for the degradation and synthesis of the glucose and other monosaccharides. So there are the several pathways are there for the carbohydrate metabolism. They are like this one. About 10 major metabolic pathways are there. They are, the one is very prominently referred as, the first one is the glycolysis, and second one is citric acid cycle, third one is the gluconeogenesis, fourth glycogenesis, fifth one is glycogenolysis, and sixth one is hexose monophosphate shunt, and uronic acid pathway, and galactose metabolism, fructose metabolism, and amino acid mucopolysaccharide metabolism. So these are the very major pathways which are referred to the metabolism of the carbohydrates. In this picture, you can come to know, have an idea, rough idea, how this glucose will be undergoing the chemical reactions in various aspects of metabolic pathways. The first glucose entering into the cell, it will be formed into the glucose 6 phosphate. So if there is excess amount of the glucose, that will be stored there, the glucose, and that storing is called as the glycogen. And if glucose is converted into the pyruvate, and from the pyruvate it may be converted into the lactate in the absence of the oxygen, which leads to the formation of lactate, and it may be converted into, or going into the pentose phosphate pathway, or once it forms into the pyruvate, it may go into the citric acid or TCA cycle, where there will be release of the energy along with the water molecule and carbohydrate, carbon dioxide molecule. So this is the fate of the glucose, how this in different way it undergoes various pathways for the sake of metabolism. We will take up with the glycolysis. That is the first major metabolism pathway. So what is the meaning of glycolysis? It means splitting of the sugars and process of releasing the energy within the sugar. Two things, that is splitting of the sugar and releasing of the energy. So it is a catabolic reaction where the splitting or breakdown of the components takes place and there will be the release of the energy. So it comes from the Greek word where it refers to glycase means sweet, lysis means the breakdown or splitting. As some scientists have been involved in the final confirmation of this pathway, it has been referred with the scientist name only, and also it is referred as the embedded Merov pathway or EM pathway. Another thing is that it can work out with the presence of either glucose or also in the absence of the glucose also. So in the presence of oxygen, glycolysis is the first stage of the cellular respiration. So you will learn more about this one in another topic. Here it is that in the presence of oxygen, it is the first stage of the cellular respiration, and to be remembered that it takes place in the cytosol of the cell cytoplasm. So the first step in understanding the glycolysis, it started with the 19th century. There you may have heard the name of Louis Pasteur. So he was studying about the fermentation by the action of living microorganism. So he related to the glycolysis aspect. However, he started to give some idea about it. And another scientist, Eduard Buchner, he was the one who discovered cell-free fermentation, and one another scientist in 1920, Merov, who involved in completing the puzzle of the glycolysis with all these pieces available in by the 1930. And finally, the Embedden, he proposed step-by-step outline of this pathway, and now which is called as the glycolysis. So these were the scientists who directly, indirectly contributed for the pathways of the glycolysis. So the definition goes this way, that it is defined as the sequence of the reactions converting glucose or the glycogen into the two molecules of pyruvate in the presence of oxygen. If the glucose is converting into the pyruvate from the glucose, it is referred to as the process taken place in the aerobic condition. Aerobic means in the presence of the oxygen. And if it is forming the lactate from the glucose, then it is referred as the anaerobic situation. So in both the conditions, there will be the production of ATP, and it is also called as the Embedden-Merov pathway. So you must know the definition for the glycolysis. Glycolysis is that it is the one pathway which has got the sequence of the reactions. There are 10 reaction steps are there in the pathway of the glycolysis. That is, first thing is that breaking down of the glucose or the stored form of the glucose, that is glycogen, into the pyruvate. The pyruvate will be the end product when this reaction is taking place in the presence of oxygen. And if there is a product formed, the lactate, that is the one which is referred as the one which has taken place in the anaerobic condition. And both the conditions, there will be the release of ATP, and this one is referred as Embedden-Merov pathway. It should be remembered very well. Okay. So it is a pathway which has got the sequence of 10 enzyme catalyzed reactions that converts glucose into the two molecules of pyruvate and simultaneously production of two molecules of ATP, and the two high energy electron carrying molecules of the NADH. Along with the ATP, there will be the formation of the molecules, two molecules of NADH. So same thing, it includes the formation of lactate from the pyruvate. So in aerobic organism, glycolysis is the prelude to the citric acid cycle and electron transport chain, and glycolysis can be considered as the central pathway for the glucose metabolism. So from there it goes to the citric acid one, and where there will be the formation of glucose 6 phosphate, which will be a main component in the glycolysis. From there it may go to the pentose pathway also. So you can claim that glycolysis is the central pathway of the glucose metabolism. So this pathway occurs in the cytosol of the cell, and next stage of the cellular respiration, that is called as a citric acid cycle, that occurs in the matrix of the cell mitochondria. So you have to remember that in the glycolysis there will be the breakdown of the glucose into the pyruvate or the lactate. The pyruvate formation takes place in the presence of oxygen, which is referred as the aerobic one, and there will be the formation of lactate from the glucose, that is referred to as an anaerobic condition, and this takes place along with the release of the energy, that is the form of the ATP and also NADH. Now coming to some silent features of the glycolysis, we see these things before we go to the steps of glycolysis. It occurs in all the cells of the body. It is not pertaining to any one organ or any particular tissue like that one. So it occurs at all the cells of the body, and this pathway converts the 6 carbon glucose into the two molecules of 3 carbon compounds, pyruvate or lactate, and it is the unique one that occurs even in the absence of the oxygen, which we are calling as the anaerobic pathway, or pyruvate is happening, it is aerobic one, and with further from the presence formation of the pyruvate, it goes into the pathway of the citric acid, and there will be the things, what end product will be there, they will be carbon dioxide and water molecule. It is very much essential for the brain, means because of the glycolysis the brain can get the glucose. There must be always the supply of the glucose to the brain, and not only this one, the intermediates of the glycolysis, they are the one required for the synthesis of the amino acids and fat. I said in the earlier one that some of the products of one chemical pathway can be the reactant or the substrate of the another component. This is the beauty of the metabolism. So here the intermediates of the glycolysis are useful for the synthesis of the amino acids. The reversible of the glycolysis along with the alternate arrangement at the reversible step will result in the synthesis of the glucose. Means the synthesis of the glucose from the non-carbohydrate one, it will be also having some pathway. So those pathway steps will be the some steps related to the steps of the glycolysis. So that can be referred as the gluconeogenesis. We will see those things in the later on stages. The mammalian brain requires continuous delivery of the glucose from the blood. Glucose metabolism, it produces the supply or the energy fuel you can call for the brain function through the generation of the ATP for the neuronal and non-neuronal cellular maintenance, as well as the generation of the neurotransmitters. The thing is that the glucose is required continuously the supply to the brain because for the these things. One is the generation of ATP will be there for the neuronal, non-neuronal cellular maintenance and also generation of the neurotransmitters. So very tight regulation of the glucose is critical for the brain physiology. The disturbed glucose metabolism underlies the several diseases affecting both the brain itself as well as the entire organism. So when the person is deprived of blood, sugar supply, then he will be in a confused condition, and also further if the things are going worse by worse, then other organs also get affected by this one, which may lead to some type of the diseases. So the glycolysis pathway can be divided into the three phases. There are the three phases. So these three phases, it has been given in the U Satyanarayana textbook, whereas some other authors, they are referred with only the two phases. Don't get confused one. It is three steps are to more understand the things, it is given there. The one phase is energy investment phase or priming stage, where there will be the involvement or the requirement of the ATP will be there, and then splitting phase where there is a two molecules of glyceraldehyde will be formed, that is the splitting phase, and later on there will be the generation of ATP will be there at the end of the reaction, which indicate about the phases related to the energy generation phase. So these are the three phases that are involved in the steps of glycolysis pathway. Glycolysis pathway has got 10 reaction steps which are classified or broadly considered into the three phases. Phase 1 is the energy investment phase or the priming phase stage, and second one is splitting phase, and third one is called as the energy generation phase. So these are the three phases related to the glycolysis pathway. So I will stop here only. The next part will be taken tomorrow. So until now we are seeing that one. What is the background for the start of the metabolism? That is the digestion aspect. That in the stomach the digestion start, and there from there to stomach where there will be any role of the stomach in the digestion, then it will be passed on to the intestine, it will be acted upon by the enzymes related to the pancreatic intestinal juices, and then it will be taken into the portal vein store and then to the liver. In the liver the glucose is converted into the glucose 6 phosphate, where it is irreversible one, that reaction, and glucose 6 phosphate once it is formed, it will be taken into the various other metabolical aspects. It can be as the glycogen storage of the glucose. A second one is the formation of that one to the pyruvate by the glycolysis, and third one is the pentose phosphate pathway, or from the glycolysis pyruvate formation it may go to the citric acid cycle. Like this one, different pathways can be started from the glucose 6 phosphate. So you have seen that one, what is the importance of the metabolism, types of the metabolism, and then coming to the glycolysis, what is the importance of the glycolysis, and how many are the stages are there. About 10 stages are there that we will start from there. Tomorrow we will see to that one, and then the Another one is these reactions are classified into the three phases, that are the one is the investment, energy investment, and second one is the splitting of whatever molecules that will be forming, and third one is the energy production, that ATP formation will be there, which we can learn in the 10 steps that are involved in the glycolysis pathway. Okay, thank you.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, beta.
Thank you, sir.
ಹೌದು ಅಂದ್ರೆ ಇವತ್ತು ಎ ಸಿ ಕೆಳಗೆ ರಿಪೇರ್ ಮಾಡತ್ತಾರ